So, continuing trying to solve some questions of the max. Here we have from the undergraduate Math 8 2013 question 3. Okay, so he's telling you that this line AB, A to B, is actually the diameter of this semicircle, and you have a point B that can be in anywhere of this semicircle. Okay, but what he tells you is that if now tracing this and over here, okay, he's telling you that this angle is X. Okay, the angle ABP is X. So the question one is asking you, what is the area of the triangle APB in terms of X? In terms of X. Okay, so I'm giving you a tip. This angle over here is 90 degrees. Okay, it is 90 degrees. If you want to try to solve it by yourself, try now. And okay, so I'm going to start solving. So number one, if you didn't know that this angle is 90 degrees, well, look, if we imagine it's not, we don't know yet it's 90 degrees. Okay, so tracing this line over here, it is the radius too. Okay, this line over here, OP. So this one is equal to this one and this one. So look at this triangle over here, OPB, the triangle OPB. Okay, OPB. You have it is an isosceles triangle. Okay, so if this is X, this would be X2. Okay, another thing that you have is that this triangle, the triangle OAP, is isosceles too. So if this is theta, this would be theta 2. Okay, so in the big triangle APB, look, APB, the big triangle APB, which angle, what angles does he have? So theta plus X plus X plus theta, and if you add them together, it's a triangle, so it must be 180 degrees. Okay, so you'll have that 2 theta plus 2x is equal to 180 degrees. So theta plus x is equal to 90 degrees. Okay, this is why this one is 90 degrees. 90. Okay, now if you didn't know about this, you can search in Google like a triangle in a circumference with the diameter being one of his sides. Okay, so if you search this, you can find more about this. Okay, so now that we know that this angle is 90 degrees, we can find the area which question 1 is asking. So look, I'm going to call this AP as A and BB as little b. Okay, so A P is equals to A and P B is equals to P. Okay, so what we actually have over here is a triangle like this. Okay, this being A and this being B. What is the area of this triangle? Well, it's the base versus the height divided by 2, the area of triangle, right? Now look, we need to say this in terms of the x, right? This is what the question is saying. So we'll use a bit of trigonometry. So sine of x is equals to the opposite, which is a, divided by the hypotenuse, h. Okay, so and h is equal to 6. Okay, and so a, which means that a is equals to 6 versus sine of x, right? So cosine of x is equals to, well, cosine is the side divided by the hypotenuse, h, this side over here, which is 6. So b is, oh shit, everything good, everything good. So b is equals to 6 sine x. Okay, so in place of a and b, we're going to use 6 sine of x and 6 cosine here, sorry. b is equals to 6 cosine of x. Okay, so remember our formula for the area, a and b. So a is 6 sine of x versus our b, 6 cosine of x divided by 2. Now 6 versus 6, 36. Shit, mate. Divided by 2 is, and sine of x versus cosine of x. Okay, now this would be the answer, but you can make it better. Okay, so there's something like sine of 2x, so it is equal to sine of x cosine of x plus sine of x cosine of x. So sine of 2x is equal to 2 sine of x cosine of x. This formula is from trigonometry. Okay, this would be the answer. They would accept this, but if you want, you can say that. So remember, the answer was 2 versus 9 versus sine of x cosine of x, right? But 2 sine of x cosine of x is sine of 2x, so you could say that it is 9 versus sine of 2x, or you could let it in 12 sine of x cosine of x. It is the same. Okay, so yeah, this would be the answer for question 3.1. Now this one over here, it will help us in the question 3.2. Okay, so question 3.2 is asking, find the range of x for which the area of the triangle that we just counted, maybe, so the triangle, the area of the APB must be bigger or equal to 9. And now look, if you want a tip to try to solve this by yourself, use this formula we found for the area in question 3.1 and use a bit of trigonometry to prove this. Okay, I hope you tried. So now let's try solving it. Now look, 9 sine of 2x, which is the area, this is what we calculated, a formula for the area of these triangles in term of x. Okay, so this one must be bigger or equal to 9 square of 2 divided by 2, right? So we can divide by 9 in the two sides. So we'll have that sine of 2x must be bigger or equal to the root of 2 divided by 2. Now this is where you will need to use a bit of trigonometry. So look, the sine in the trigonometry, we found this last, okay? This was the last thing that we found, and now we need to make it better, let's say. So look, the sine starts from 0, right? Sine of 0 is 0, and he goes up, up, up until sine of 90, right? Which is 1. Here. Sine of p equals to 1, right? So he goes up, he reaches the top, and then he starts going down, 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 down until 0, and then he starts being negative. Remember that the sign is over here, okay? It varies this way. So 0, and then he starts going up. Remember this? He starts going up, and then he starts going down, but still positive, okay? In this side he's still positive, and then he's going to 0 again in 180 degrees, and over here he starts getting negative, negative. So if mate, come on. So if we want him to be bigger than this square root of 2 divided by 2, we need him to be over here, right? Because smaller than this, he's going to 0, and smaller than this is 0, and then we have square root of 2, then 1, then square root of 2 again, right? So this square root of 2 divided by 2 is actually 45 degrees, okay? Or you can call it p divided by 4. So we know that the 2x must be bigger, the angle must be bigger than p divided by 4, and smaller than this other one. But what is the value of this other one? Well, you will need to do 118 minus 45, which is equal to 135, yeah, degrees, okay? So this 135 degrees has the same angle as the 45 degrees, okay? And if you want, so p minus p divided by 4 and 3, yeah, 3p, this one, 3p divided by 4, okay? So but we don't want 2p, we want only x, we don't want 2x, we want only x, okay? So x must be bigger than p divided by 8, going this way, 2 divided over here, and smaller than 3p divided by 8, okay? So in 3.3, remember that this was the triangle that we had. So yeah, I think like the fact that there was a circle and all that, it was just so that you can know that there is a 90 degrees over here, and that this side is 3 and 3, which is 6, okay? Because the diameter and this is the radius, right? Radius, okay? But now in question 3.3, he's telling you that if the point P is so chosen that PA and plus PB, so PA is little a and PB is little b, he's telling you that this plus this is 3 square of 6, okay? What would be the area of the triangle APB? So look, you will need still to use that A versus B, which is the base versus the height, divided by 2 is equal to the area. But you will need to use a bit of I think it's called factoration. In Portuguese it's fatorial. Factoration. I don't know how to write it, but so try to solve it, and now I'm going to solve it, okay? One more tip, okay? So use the term of Pythagoras. A squared plus b squared is equal to 3 plus 3, which is 6 squared, 36, okay? You can use this too, so to solve it, okay? If you didn't do it, try again, okay? So okay, now I'm going to solve it. So the thing is, look, knowing this is a thing of practice, okay? So look, we know that we want to find this. This is our objective. We want to find a versus b so that we can divide it by 2, and then we'll have the answer. So the objective is to find a versus b. But we have a squared plus b squared, and we have a plus b. So what we can do is that we can say that, one second. So we can say that a plus b, and we put it squared, is equal to 3 square of 6 squared. Okay, so I just put squared in the both sides. So a squared plus 2 versus ab plus b squared. And what I did here was just like doing a plus b versus a plus b, okay? So if you want to do it like this, so this one, and look why I did this, because I knew that it will appear a squared and plus b squared, okay? And I have a squared and b squared, and what I want is a plus b. So this one squared is 9 versus 6 is 54. So a squared plus b squared is 36, right? Plus 2ab is equals to 54, right? So now we'll have the 54 minus 36, okay? So 2ab is equal to 54 minus 36 is this number that I never remember. So a versus b is equal to 9. But what we want is the area, right? So a versus b divided by 2. So 9 divided by 2. And yeah, this is for question 3. If you want, you can say 4.52, okay? It's the same. They will accept both answers. So I hope you understand. So just a quick review. So we use the information that when we have the diameter as one of the sides of a triangle that is in the circumference, this side over here is 90 degrees, okay? So we use this information, and then we use the information of sine and cosine of x to find to say we said the sides a and b in terms of sine of x and cosine of x, so that we could find the area of this triangle in terms of x, okay? So this one is for 3.1. Now 3.2, to be honest, it was like, yeah, it was a lot of trigonometry. So if you had difficulty in 3.2, review trigonometry. But like, yeah, that was it. And for 3.3, we used what we already knew about this triangle, and we used factoration, and the information like a plus b is equal to 3 square of 6, and the Pythagoras to find the a plus b, okay? So if you have any suggestions, yeah, just tell me.